Welcome back to 521. We're going to be talking about graphing these inequalities on the coordinate plane. Now, when we see a less than or a greater than, we're going to use a dashed line. That's kind of like our equivalent to an open dot. Less than or equal to, greater than or equal to, we use a solid line. That's our equivalent to a solid dot or a closed dot. So keep that in mind on what type of line you're going to use when you draw your graph. Now, number 13 is a quadratic. Now, our vertex is at 2, -4. And our leading coefficient A is 2, which means we have a vertical stretch. So now, here's my anchor points. Now, the vertical stretch means we're going to multiply those outputs by 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. And the other points are off the graph. Now, we're going to shift to the right 2 and then down 4 because of our H and K. So go to the right 2 and down 4. To the right 2 and down 4. To the right 2 and down 4. Right 2 down 4. And there's our points. I'm going to get rid of the other ones. So that's where our points are going to be. Now, because it's greater than, we're going to use a dashed line. Now, we're also going to have some shading that needs to occur, whether we're going to be shading inside or outside. And just like we did before, pick a test point. Now, it doesn't matter where your test point is, if it's inside or outside. I like using 0, 0 if possible. And that's not on the graph. Only thing we can't have is a point on the graph. So I'm going to test 0, 0, because it's easier to work with. So 0 is greater than 2 times 0 minus 2 squared minus 4. 2 times. 0 minus 2 is -2. -2 squared is 4 minus 4. Greater than 2 times 4, which is 8. Minus 4 is 4. Now, we get 0 is greater than 4. That's not true. My test point outside didn't work. So our solutions are not going to be on the outside. They're going to be inside the parabola. And that's where all of my solutions for that inequality be located. They would all be located inside of that parabola. Let's go to the next page. Problem number 14. Here's an absolute value. So our vertex is at -3, -2, and A is a +2. So with these, the easy way to graph them, plot the vertex. -3, -2, and A is our double slope. That means we're going up 2 and over 1 in both directions. That gives us our V-shaped graph. Oh, excuse me. And we're not going to use a solid line. We're going to use a dashed line. Because it's just less than. So now, pick a test point. If I can use 0, 0, I try to use it. It's just easier to work with. Doesn't matter if it's inside or outside. If it works, shade where it is. If it doesn't work, shade where it is not. 0 less than 2 times the absolute value of 0 plus 3 minus 2. So 0 is less than 2 times the absolute value of 3. Minus 2, 0 is less than 2 times 3 minus 2. 2 times 3 is 6. 6 minus 2 is 4. Now, 0 is less than 4. That worked. My test point was outside. So since my test point worked, I'm going to shade where the test point is. And in this case, the test point is outside of... Okay, let's look at problem number 15 now, please. For number 15, A is -1. So that means there's an x-axis reflection. And the vertex is at -2, 3. So that means we're going to the left 2 and up 3. So our anchor points are here. Now our x-axis reflection, we multiplied the outputs by -1. And there's our x-axis reflection. Now what we do is we take each point and go to the left 2 and up 3. So I'm going to get rid of those points up top. We don't need them. Left 2 and up 3. Left 2 up 3. Left 2 up 3. Left 2 up 3. And go to the left 2 up 3. Left 2 up 3. Left 2 up 3. So to unclutter a little bit, get rid of all those other little points I don't need that aren't the x's. And our graph, it's a dashed line through these points. Now, I don't like how close I am to 0, 0, so I'm not going to use that as my test point. I'm going to pick a point in between this time. I'm going to pick a test point at -2, 0. So 0 is greater than the opposite of -2 plus 2 squared plus 3. The opposite of -2 plus 2 is 0. 0 squared is 0. So we get 0 is greater than, now there's no such thing as -0, but when we add 3, we get 3. So 0 is greater than 3. That is not true. Our test point was inside and it didn't work. So our shading is going to be on the outside. And there is our graph. Let's do one more. And this is what we call a system of inequalities. Now the first graph, A is 1. And our vertex is at 5, -4. So I'm just going to make a quick sketch of this. We're at 5, -4. And here's where our points are going to be when we graph them. You can even use Desmos if you'd like to for these, just to kind of save a little bit of time. Now that top one is going to be a dashed line. And now let's pick a test point. I'm going to pick 0, 0 for the first one. 0 is greater than 0 minus 5 squared minus 4. So 0 is greater than. -5 squared is 25 minus 4. So 0 is greater than 21. That is not true. So what we would be doing for that one is we'd be shading on the inside. Now I'm not going to shade everything. I'm just going to put a couple of arrows here saying shade inside the parabola. Now for the second graph, A is -1. And our H and K, our vertex is at 3, 3. There's 3, 3, and A is -1. So our graph for this is going to look like this. And we're going to use this time a solid line because it's or equal to. And now I'm going to pick a test point that's not on the graph. I'll use 0, 0 again 0 less than or equal to the opposite of 0 plus 3 squared, 0 minus 3 squared plus 3. So 0 is less than or equal to 0 minus 3 is negative 3. Negative 3 squared is 9 times negative 1, so we get negative 9 plus 3. So 0 is less than or equal to negative 6. That didn't work either. So 0, 0 is on the outside. We're going to be shading inside that parabola. Now, it has to work for both. So we're going to shade that overlapping region on the inside, which is right down here. That smaller shaded region is where all of the solutions of that system of inequalities is. Okay, thank you. We just finished up chapter 5. I will see you in the next chapter.